big data with requirements and taxonomy. And our presenter is Dr. Asif Nawaz. He received his PhD in electromagnetic field and microwave technology from Beijing University of Post and Telecommunication in 2010, and an EMBA from Lahore University of Management Sciences in 2012. Presently, he is working in HCT as an assistant professor of electrical engineering in the Engineering, Technology, and Sciences Department. He has recently completed Certified Future Foresight Influencer and Practitioner certification. He's also a PMP certified. Dr. Asif has worked for around 18 years in the industry with diversified experience that includes but not limited to digital transformation, project management, planning, and operation management. With all that experience, we look forward to your presentation. The floor is yours, Dr. Asif.
Okay, thank you, Dr. Samar. Thanks a lot. Thanks for this generous introduction. Ladies and gentlemen, good afternoon. We are going to discuss today latest advances of Internet of Things and then the big data. Okay, and I'm Asif Nawaz. So we call it Internet of Things or Internet of Everything, and it came from the concept of M2M, which was machine-to-machine communications. Okay, the idea behind this was that we have sensors across the world, and we connect those sensors somehow to some platform, and in our case it is a cloud or is through the internet or whatever wide area network, and then we do processing of that particular data. So in this particular paper we had tried to evaluate the sensor side, the data storage sides, and the analytics sides, and what are the latest trends in this for doing the same. So again, the motivation for all of these things is that we are having very high speed switches in communication. We are going to have very high data storage fabrics. We are going to have very brilliant machine learning and business analytics and decision making stuff. And of course, last but not the least, we have very nice sensors embedded on the chip which take certain inputs, and then they transmit that data to the cloud and for our decision making. So just to give you an idea, the IOT, or again I use it as a buzzword or word, Internet of Things or Internet of Everything. This is something you connect everything to a network. IPv6, thanks to IPv6, that's another topic that has given us the capability to connect all of the devices, trillions of devices, hundreds of trillions of devices can be connected. In 2016, we were having 22.9 billion of devices which are connected, 3 to 4 times the population of the Earth. In year 2020, we are going to have 50. It is 7 to 8 times of the population of the Earth. So what are different market segments, or the some of the market segments is the microgrid. So this is the new concept. Since I'm an electrical engineer, I know that the microgrids are basically all the humans or the households, I'll say. All the households in the world, they are generating their own power, okay? And they are transmitting that power to either their neighbors or to the utility. The best thing is they transfer their power to the utility, and the utility then transmit the power to the other customer. Again, we need sensors, we need data, and we need the decision making how to do that thing. So this is one thing. This is smart grid or virtual power plants, and this is the hot topic in power engineering and the energy sector these days. Smart consumer. I'm the smart consumer, so if my data, all of my data is there onto the system, it can be used for certain decision making. Maybe they can produce some customized products for me. That's the niche, because in the marketing we see there is something which is called segmentation. You segment the customers. So smart consumer data, it helps you a lot to create the customer segments or something. Smart healthcare. This is again the need of the day. Telehealth, telemedicine, e-health. Even you have embedded devices into your body, and those give the data to whole of the doctor, but it should be at runtime. And in the previous presentation, I just mentioned that we need on-chip memory access. So hardware also has to be very robust and low latency. But in this presentation, we are not discussing this, but we are assuming that we are very good hardwares, they are very good decision making, they are doing very low latency, a very good computational complexity, etc., etc. Performance in computational complexity. Smart transport, intelligent transport system. I go to E11 in Dubai, Sheikh Zayed Road, and in the mornings, in the night, in the evening, it's the nightmare. So why not to have a very good, smart, intelligent, self-organized, self-decision-making system which can evenly distribute the traffic in whole of the city? Again, sensors, data, and decision. Then next is smart factories. Of course, this is whole of the topic which is industrial IoT. I'm doing a project with my students on the smart supply chain for industrial IoT. So basically, the factories, they need to reduce costs and increase productivity, quality, and products. So these smart factories can also use again the sensors, data, and data analytics. Smart cities, whole of the cities, they are interconnected, so there are camera, facial detections. So I saw a video 3 years back in China that a person showed up at one place in a city in China, and the police found him out in maybe 8 to 10 minutes, just doing the facial recognition and then finding his location, and they've reached 8 to 10 minutes. That's it, from the populations of maybe millions. So smart cities, they have very huge potential. And then the smart building, you need to control your building for efficiency and sustainable. So there are many, many areas we use IoT and their applications, but the basic fabric is same. Three things, and which we are touching is something which is the sensors, number one, data storage, number two, and data analytics, number three. Of course, interconnectivity and the connections between them is also important. So there are two types of architectures for this IoT based system. One is the broker ESB based, which is called MQTT. The other one is DDS, which is on the distributed system, and broker ESB based, and this is basically used for smart appliances and those things which don't require real time data. This is for use, DDS is used for which we require extensive amount of real time data. As you can see the architecture, if you want to reduce the cost, you will use broker or ESB enterprise service bus. And if you are using this high speed, low latency, very quick decision making, maybe for medical or military purposes, you'll use the DDS systems. Okay, and then you use the sensors and those things. You can see the details on the paper and the slides. So MQTT, again, this is for telemetry, centralized server based, and logic integration. This is slower. This is intelligent system within the chip, dedicated, real time, and this is embedded and at the edge. So that's very fast but very costly. That's good optimized, and it is for the business and commercial purposes. The difference is the network, both of them use LAN WAN, and some configurations are ITs involved. This is not. This is a few messages per second. Again, the architecture you see, this is 10,000 messages per second per device. It's very fast. Latency is high, low. Timing is not stringent. This is the timing base. So if a drone is flying at a speed of 300 to 400 kilometer per hour, and it has to detect some face and has to make immediate decision. Imagine there is an application that a drone has to fly to a certain place where there is an accident, and on the basis of that, he just needs to take the drone. It needs to take the pictures and decide which and some diagnostics, of course, and decide which patient is more critical to lift to the hospital. And suppose the drone can contain or pick or lift only one person, so that decision has to be done in just like this instant of time. And for that, we need these DDS systems and good amount of data and good decision making. Now, this is one of the many and hundreds of applications you do. Fault tolerance. In this case, service interruption is tolerable, but in this case, if the drone is there and there's some communication failure, or maybe the battery goes or the system hangs, then there's a problem. It can cost lives. And the protocol level, so here interoperability is at a protocol level. It is at application and the protocol levels. Okay, so there are certain research in this area. Gill said that the framework is composed of three components, and which is the motivation for us: data analytics, big data management with data storage and sensors. Then there is something research which Lee said is on the body area networks. Again, this is very critical data, embedded DTS systems. Then we have an IoT structure that viably performs parallel examination assignments. Of course, parallel processing, distributed and parallel computing is something which is very important. We have to do. Discharge the report of a set of a framework for the parallel information. Mukherjee said this, and then a system for observing and analysis of expansive sums of information. So when we talk about big data, the story doesn't start or doesn't finish without Hadoop. Okay, And Hadoop is quite inspiring because this is a big data storage setup and it has multiple applications. On this side, if you go, there are tens of certain application and the packages for Hadoop which you can use for this. So basically this is used for data storage. It is the application level management and data, not dependency on the hardware. That means that hardware is independent on the Hadoop application, means that it has some virtualization layer in between so that it manages fault tolerance. And Hadoop decimated record framework HDFS is something which is very important. It is good, but it it can go to unlimited space. It can just scale up to 10,000 of machines, but for lower number of machines this is not efficient. There's no encryption in Hadoop, so it means your data, if someone cracks into Hadoop, then you're gone. And then adaptability is also, again, for the small number of devices is not feasible. For details you can go to Hadoop and there are a lot of things over here. 1010 data, and now this is using a third party system as well and is doing the data processing and analytics. It takes the data and it does basically three things: market intelligence, what type of customer we need, and the people who understand business, and we know the business, that customer segmentation, customer targeting, and the niche market deployment of a certain product is something which is very important. Why Apple is more successful, and why in UAE all of the people they use Apple. There is something, and on the double of the cost. So this is basically the market intelligence of Apple, which it does on the area basis and then makes certain products. So market intelligence is basically you know the customer before the customer knows himself. Very important. You know the customer before the customer knows himself. Then you do enterprise analytics, how we can sustain and offer our businesses to make the customer needs, and then there are certain collaborations that many people can connect. So again, in my supply chain project, what I'm doing is this is something which is called that different entities, they are connected with the same information set. So this 1010 can be used to connect different industries at the same database so that everyone can access, and there's very least delay for supplying and transportation and very low cost for that. And this is providing, basically, we have heard about platform as a service, software as a service, application as a service. This is data as a service. So 1010 data, another horizon to provide data as a service applications. Cloud era. So this is, again, does the decision making, and this is a service power. So if I want to open my own company, I can just go to cloud area. I got some allocation and can do everything, and they can suggest in my business decisions. So these are open source technologies that deliver the widest range of analytical workloads with security, governance, and control, and overall performance, reliability, protection, and these things, these are done over here. So these are three giants. There are many, there are top 10, so we can use any one of them for data storage and data analytics. Connectivity, again, the major area. You need to connect the devices, and those connectivities should be not like poor signal like we do in our BBL classes or something. It should be robust. So there are different protocols, protocols for connectivity. We have wired connection and we have wireless connection. In wireless, we go to Wi-Fi, which is the free band, and then we go to the paid band, which is the cellular network. We have come to 5G and the terabyte backbones as well. And as I told you, when I was working in Ericsson, we were on a project for Telenor One Asia. So Telenor was going to converge whole of the Asia cellular market into one cloud-based system. Imagine the scale. And Ericsson, my company's solution was that we had the hardware, and those hardware were connected from the back fabric through the optical on-chip communication channels. So normally the processors, they communicate electrically within each other, but we are having a big cloud. So on the cloud, they are connected through optics, and this is very fast. But if you have to connect, what if you have to connect in 3 continents? Then you need the connectivity. This is called wide area connectivity. And then we have the metropolitan area networks, and the LAN and the bands and PANs and all these things. So connectivity, we need to integrate huge sum of sensor information, and that should be going to the cloud and the data. And the storage, the other thing is storage. You need, again, these huge clusters. These are on the back end, they are connected, they are for fail safe. So the connectivity can can be optical, it can be electrical, because this is on site. But what if one of them is in Atlantic, across the Atlantic Ocean, and another one is in Australia? So they need to be connected through high-speed optical fiber links, and we need to see the delays. And when you go to the delays and we see MQTT, that can help, but DDS may not. So we have to think on this. Quality of service, when you talk about Internet of Things and customer satisfaction, of course, there is something the customer needs, a quality. At least I don't go to a shop for the second time if they deliver something to me of the bad quality for the first time. And same is the case for the word. So quality of service is also important, and applications and users, this is the business requirement, they lead towards Internet of Things solution. And then we need to have a quality of sports. So then coordination of QO structure, again, this is the data analytics, and we see that how we can improve the quality. Real-time analytics. Again, as I told you, that we need to analyze the data and make certain decisions, and it should be real-time. Imagine same thing, a drone ambulance which is going to capture the sensing information and the images, and it has to make decision that which of two people out of these 4 or 6 people are critical and I need to take them to the hospital. So this is real-time analytics, and there are certain platforms for this as well. So if you see towards the taxonomy, the sources of big data, we can mainly say that, okay, city management, city gives the immense amount of data. Manufacturing, the industry, intelligent transport system, they give us the data. Smart buildings, they give us the data, huge amount of data, and monitoring sensors. So I use Diva, and Diva gives me, okay, how efficient I am as compared to other people in my area, and how efficient I am from the last year of electrical consumption. So all these things, decision making, that gives the sustainable environment. System components, you acquire the data, retain the data, transport the data, process the data, and then leverage the data for certain new businesses. Enabling technologies are ubiquitous: wireless communication, real-time analytics, machine learning. Of course, this is the decision making, and machine learning is nothing but just to make a decision on the basis of previous experience. So it has a previous experience of learning something, and on the basis of that, when it gets some new thing, it decides, okay, what to do, what's that. So that's machine learning. Machine is learning on the basis of the experience it has. Again, there are supervised and unsupervised machine learning, we know that this thing. And then community sensors. Functional elements, very simple. We have inputs from the sensors. Those inputs are doing computed. Yes, there are certain policies and rules implemented, and there are certain outputs. That's it. And once we do analytics, there are descriptive analytics. Descriptive analytics is learning from the past. Predictive is you anticipate or extrapolate, or what you call is regression something. You do it for the future. And prescriptive is that you take a certain strategy on the basis of certain predictions that leads you towards that future. And that's something, the crux of our future foresight influencer training, that the future is coming, but can we change the future? And the answer I learned into that certification is yes. Preemptively, with certain predictions, you can drag yourself to the future you want. So that's something which is great. And IoT, thanks to IoT, the concept of IoT and the building blocks and the fabrics, who have led us towards this thing. Then sources, this is something I told, that you need to store the data. There are certain system components. We do there are volume, kind, and speed, and the issues are huge information, are capturing information, what's the capacity, how you examine this information, recovery, overhaul. And how many of you go to second page of the Google if you search something? At least I never go. So if I search on Google, and there's an immense amount of information, and we need a specific information, and as of now, as you can see, that what if Google does profiling of my searches? Google knows that I use the vague keywords, and those vague keywords means something different. What if it's the natural level processing, and I can speak in Punjabi and Google does this? So all of these things are huge application of data science and IoT. Again, the key applications: input, computation, and there is some information, and there are analytics, are the clear investigation and prescient investigation and forward-looking examinations. So same thing which we have discussed. So different benefits of data analytics for IoT applications. Smart transportation, yes, they reduce. For example, there can be a business need that reduce the number of accidents. How many accidents are happening here in UAE on the daily basis? And what are the mistakes? What mistakes we learn? Minimize traffic congestion, again dynamic distribution of traffic. Optimize shipment movements. If you are getting something, the shipments, you can optimize them, reduce the inventory cost and the buffer as inventory. Road safety is also something which is very important. In the healthcare, we can predict epidemics. Imagine. So this thing, like this epidemic, should not have been that much severe if all of our systems were in place. They were in place, but they were not in place in a smart way. And if all of the world would have information beforehand that there is something, what you call is epidemic is happening in certain area, so the transportation and the traveling from that particular area should have been optimized. So these other countries and the people, they got information late. Systems are in place, but they were not efficiently in place. So we can predict and control epidemics. We can do the cures, we can do the diseases. And over here in Dubai, we see that there's Al Hussein application, so it gives me all of the data. It's very small application of that. Why not to get dynamically to collect all of the samples and those things? Okay, non-invasive. Insurance companies
5 minute reminder, Dr. Asif.
Yes, please.
5 minutes. You still have
Yeah,
5 minutes.
yeah, please. I'm just going to finish. Then insurance companies can make better policies, because again it's the cost. If a person is not expensive to insurance, they can give better policies. And the warning signs, and then the smart grids. Of course, I mentioned this thing, that we have optimized pricing plan, and if there is a need, we can increase the cost. If I have more solar panels, I can bulk sell the electricity and so on and so forth. Inventory management systems as well. So results and discussion that IoT by individuals, yes, we'll do that, and there will be certain innovations, and there are many needs for this. Personal use of Internet of Things, of course, we'll do that, utilize individual information. Impact of Internet of Things, we'll see what impact does it have. And conclusion is that you need to characterize numerous necessities for information examination. Classification we do, the distinctive conceivable outcome mean the future we want, I should go to that future. Information examination, challenges that may occur in future. Of course, we have the virtual currency, for example, bitcoins and blockchain, and you'll have the citizens and the countries will have virtual credit. Then definitely we need to see that there is a privacy and there is a security issues as well. And these are privacy and security, these are the major issues, and some ethical as well. Regulator, centralized regulator as well. So arrangement of information in the easiest step, we need to do this. And thank you very much. So the challenges which we can face in future is, in my opinion, number 1, security, number 2, privacy, number 3, ethical stuff, and number 3, the regulation. Who will regulate this whole of borderless education, university-less education, bankless banking, hospital-less medical health, and so on and so forth. Thank you very much. If you have any questions, you're most welcome, please.
Thank you, Dr. Asif. And we'll leave the floor for our attendees if they have any questions. If you have a question for Dr. Asif, please unmute yourself and ask him.
And I can be contactable at my email and through Dr. Samad. I'm working in HCT, so that's fine, not an issue. But this is huge. So any questions? Yeah. Please.
Let me start. Maybe encourage others to ask questions. I'm always, when it comes to IoT, and I think maybe I asked the presenter yesterday, what is the state of IoT today? Where are we? Are we still at a point where we're trying to find a use for IoT, or it's the other way around? No, there is a need for IoT, but there isn't enough application of it. So who's driving who? Who's in the driver's seat, business or the technology itself?
Business. In my opinion, business. Why? Because again, if you're in enterprise architecture transformation, and that's a field, we want to transform the whole of the enterprise of the world. And it starts from business, then it goes toward application, and then it goes towards technology, and then it goes towards processes. So on the top is business, and then we have applications of information, and the third one is technology, and then is the processes. So businesses, although the technology fabric is ready and it has immense and huge potentials, But business needs will require which type of IoT solution, because at the end of the day, this is the cost. I have to make my business feasible. I can't use a supercomputer to run a grocery store. I don't need that. So this is pay as you go, or in project management you say it's progressive elaboration. So it has to be progressively elaborated on the basis of the business needs which come on the yearly basis. So
I think we're in agreement of what it should be. Of course, this is the, I mean, if we even go back to the dot-com bubble, it was the other way around, and we understand that it should be business. But my question is, currently, at the current state, and from your own research and literature that you've read, are we really there? Are we really at a stage where businesses are saying we need more of IoT, or this is my maybe concern, if you will, like, oh, we have IoT, let's use it. Where are we today?
Okay, it should be business, as I said, but as of now, unfortunately, most of us are using technology for the sake of technology.
Yeah, that's what I thought, and that's what I wanted to ask. So there's a difference there where we should be and where we are, especially with IoT, because you have, we're all very much interested in technology, and we have all these things around us. I even buy for my house these little devices. But the question is, you ask yourself, where is like the real business need that is asking the technology sector to develop something in that area?
Again, there's a concept. I saw a movie. Again, for the connectivity stuff, a, a telecom company, they sold their chips free of cost. And at the end of the day, there are some signals, and they used to control the people. So security, this is something. And the world has to, again, that's the reason I said this thing. World has to agree on the common standards for all of the world. And this is something tricky, because in one part of the world, it is okay to have bankless banks, but on the other part of the world, no. And it's not on the banks, it's healthcare privacy, it is your money, it's your information, that's all. So it's huge. So first, regulated and business should be there, but as of now, unfortunately, most of us are using technology for the sake of technology.
Yeah. Thank you so much for this. Very interesting. And we'll see if anybody has any questions.
Yes, please.
If not, I provided in the chat a link to evaluate the paper and the paper title. Please take a moment to do that. We have a couple of minutes before the next paper. Thanks again, Dr. Asif, and it's always very interesting to hear topics and presenters like yourself. Thank you.
Thank you.